Okay, no one is ready for this. NASA just launched a satellite that can literally read the oceans like a heartbeat, and it's so precise it can detect a rise in sea level smaller than the thickness of a credit card. And guess what? It happened just weeks ago. This isn't theory. This isn't the future. This is right now. Before we dive in, hit subscribe, because space isn't slowing down, and neither are we. Now picture this. The California coastline is dark, quiet, almost frozen. And in that stillness, a Falcon 9 rocket stands tall, steam curling off its sides like a dragon waiting to breathe fire. It's November 16th, 2025, 9:21 p.m. Pacific Time. People on the ground pull out their phones. NASA teams are locked in. The world is watching. And most of the world has no idea what's about to happen. Because what's sitting inside the nose of that rocket is not just another satellite. It's a machine the size of a full-size pickup truck, built to scan almost all of Earth's oceans, every day, in real time with precision that honestly feels illegal. Its name? Sentinel-6B. And the countdown begins. 5, the valley lights up. 3, the engines roar. At 1, the ground trembles. And then ignition. A blazing white pillar erupts into the sky, carving a path through the night like someone sliced the darkness open with a torch. The Falcon 9 climbs higher and higher over California, and in those moments, humanity adds another guardian to the sky. People watching say the launch looked like the sunrise had come early, like the night itself stepped back. And for good reason, because this satellite is here to watch the oceans, but not from the shore. From 830 miles above Earth, orbiting the planet 13 times a day, scanning the water with laser-level accuracy. Why? Because the oceans are changing fast. And the changes are not the same everywhere.
Some coastlines are rising, some are sinking, some waves are swelling, some currents are shifting, some storm patterns are starting in places that never used to see storms. Sea levels can swing dramatically across different regions, and those swings can reshape entire coastlines, flood neighborhoods, disrupt shipping routes, damage ports, melt economies, and intensify hurricanes before anyone even notices. That's why Sentinel-6B exists, to be the eyes we can't have, to see what we can't see, to warn us before danger hits land. Think about this. The difference between calm oceans and catastrophic flooding can be less than 1 inch. And this satellite can spot that inch from space better than most rulers can measure a desk. Let that sink in. A machine orbiting Earth at 17,000 miles per hour can measure the ocean more precisely than the tape in your drawer. That alone should get funding. But the wild part is what happens next. Because it's not just height this satellite reads. It can detect wind speeds across the sea. It can measure wave heights in the middle of nowhere. It can estimate water temperatures indirectly, because warm water rises, cold water sinks. And warm water? That's the fuel tank of hurricanes. This satellite can literally see hurricane fuel gathering long before the storm spins into shape. Let me repeat that. It can detect the early conditions that will one day become a hurricane. Imagine knowing that days, even weeks earlier. The Sentinel-6B mission is a partnership on a global scale: NASA, ESA, NOAA, EUMETSAT, the European Union's Copernicus program. Basically, the Avengers of science got together and said, let's build something that watches the entire ocean, all the time. Meanwhile, half of humanity is arguing online about pineapple on pizza. Now here's where the story gets even crazier. Sentinel-6B didn't go into orbit alone.
Right now, literally right now, it flies about 30 seconds behind its older sibling, Sentinel-6 Michael Freilich, launched in 2020. The two satellites are flying in formation around Earth, side by side, like two police cars patrolling the same highway. Why? Cross-calibration. Think of it like this. If two thermometers in your house are reading different temperatures, you need to check which one is wrong. So for months, the satellites compare their readings, thousands of readings, until every decimal point matches perfectly. Once that's done, Sentinel-6B takes over as the new reference satellite, meaning it becomes the standard the world trusts for sea level measurements. And the old Sentinel shifts into a slightly different orbit, still working, but not as the main reference point. And here's the part no one talks about. These sea-level satellites have been watching Earth since the early 1990s. That's over 30 years of uninterrupted data. And data like that is gold. Because when you watch the oceans long enough, patterns begin to reveal themselves. Patterns that explain everything from rising seas to shifting climates to new storm formations. Sentinel-6B doesn't just take pictures. It continues a decades-long journal of our planet's oceans. It adds new chapters to Earth's diary in ultra-high precision. Now let's talk currents. You know the Gulf Stream, the massive warm river in the Atlantic that basically controls weather for half the planet? It's higher, literally taller, than the surrounding water because it's warmer. Warm water expands. This satellite can see the height of the Gulf Stream in real time, can see when it strengthens, when it slows, when it shifts direction. If that current ever collapses or drastically weakens, something scientists worry about, it could reshape global weather, crop seasons, and even the power of winter storms.
Sentinel-6B will notice the change before anyone else. Now picture this. A storm forms in the Pacific. Winds are quiet at first, but Sentinel-6B catches something subtle. A warm patch rising, the water swelling, the surface height lifting. A week later, that warm patch becomes a tropical storm. 3 days after that, it becomes a cyclone. By the time it hits land, millions of people are in harm's way. But imagine if coastal cities had that early warning, because a satellite 830 miles up saw it coming. This isn't sci-fi. This is happening right now. The instruments on this satellite, they're ridiculous. The radar altimeter sends pulses to the ocean and measures how long it takes for them to bounce back, with accuracy you could only describe as overkill. Every bounce tells a story: how high the water is, how rough the waves are, how warm the water is underneath, where the winds are strongest. From space, think about that. Our ancestors used to throw rocks into lakes to guess depth. Now we're blasting lasers from orbit to track the shape of the entire ocean. Talk about progress. And here's something fun to visualize. This satellite is basically a flying truck covered in gold-colored thermal insulation with giant solar wings. If you saw it floating above Earth, you'd think it was a sci-fi spaceship from a movie. But it's real. Humanity built this thing. Now imagine the oceans themselves. Dark, swirling, powerful, constantly shifting. Storms spinning, waves rising, currents twisting like giant blue snakes under the surface. And above all of that, a satellite watching every inch. As it circles Earth 13 times a day, it builds a map. A living, breathing, constantly updating map of sea level, wind, waves, and currents. So what does this mean for the next 10 years? It means shipping routes become safer. Coastal flood predictions become more accurate. Storm warnings get earlier. Climate models get sharper. Cities can prepare. Engineers can design better seawalls. Insurance companies can price risks more realistically. Local communities can protect homes before disaster hits. And emergency teams can respond faster. In other words, it saves lives. But hold on. Here's the part that gave scientists goosebumps. Sentinel-6B can detect long-term changes in the ocean that humans cannot sense from the shore. Tiny, tiny rises, invisible shifts, subtle swells, slow patterns that hint at bigger changes coming. It's like seeing the first domino fall before the entire chain reaction begins. For the first time in history, humanity can watch the oceans think. And that's a superpower. Right now, the satellite is still climbing into its final orbit, still calibrating, still fine-tuning. But soon, very soon, it will reveal the most precise ocean map ever created. A map with secrets, a map with warnings, a map with answers we've never had. And here's the twist you didn't expect. Some scientists believe Sentinel-6B will detect changes that challenge what we thought we knew about sea level rise, revealing hotspots, hidden currents, and early warning signs that could give us years more preparation for future coastal changes. In other words, the biggest surprises may still be ahead. And that brings us here to the moment we pause and ask, what will Sentinel-6B discover first? A rising current? A shifting sea? A storm no one expected? Or something entirely new? Whatever it finds, we'll be here to break it down. Subscribe to the Cosmos today, because tomorrow we're diving into the first hidden ocean pattern Sentinel-6B has already started to detect. And trust me, you don't want to miss what's coming.